So here's where we put everything that we've been learning in this first part of Unit 3 together. Writing and solving and graphing and analyzing a word problem involving systems of linear inequalities. So take a second and get another note card. Pause the video if you need to, because we're going to write down some steps, some notes, some questions to ask yourself about writing inequalities from word problems. And you're going to notice that I use a lot of the same stuff we've talked about before. So if we read this first problem, Sandy makes $2 profit on every cup of juice that she sells and $1 on every fruit bar that she sells. She wants to sell at least 5 fruit bars per day and at least 5 cups of juice per day. She wants to earn at least $25 per day. Show and describe all the possible combinations of juice and fruit bars that Sandy needs to sell to meet her goals, and pick 2 possible combinations that meet her goals. So, the first question I ask myself when I read any word problem is, what is being counted? Counted. And something I noticed in the problem is there are lots of things that repeat, right? Well, not lots of things, but 2 things specifically that repeat, right? 2 things that repeat: cups of juice and fruit bars. So that's something that's being counted. And another thing that we want to ask ourselves, the second thing I ask myself, are what are the totals? So I see a couple of totals. I see 5 fruit bars. So I see, let's put totals out to here. To the right, we will put totals. So I see 5 fruit bars, I see 5 cups of juice, and I see at least $25 per day. So that means we're counting things. We're counting things. And we're counting money. Right? And that's one of the last things I ask myself is, how are the totals made from what is being counted? So from what is being counted, the 5 fruit bars is made from fruit bars, but I don't know exactly how much because it's at least, and we'll talk about that too, because we want to look for keywords and associations. So I see that there are 5 fruit bars per day. I don't know how many fruit bars, so I'm going to give that an X, and it's a thing. So I don't see any money attached to it. And then I see 5 cups of juice per day. I don't know how many cups, but I know it's at least 5. So I'm going to give it a variable, but it doesn't have any money attached to it. And then I see that there's $2 on every cup of juice, right? I know that every means that it's associated with that variable. So 2 cups of juice right? And $1 for every fruit bar adds up to the money. So I look for associations, right? This every, I know that means multiplying. I don't know how many cups of juice. When I don't know how many of something, I know that's a variable. I've given that y on my table. I can give this x, and then everywhere I see fruit bars, I can write x. So fruit bars, x, and then I can write y everywhere I see cups of juice, y, and then juice, right, y. So now I can put in my other keywords, and I see the keywords associated with inequalities, at least. Also, we could look for no more than, at most, things that are associated with being not just equal to something. So at least means that it needs to be above 5 no matter what. Above 5 no matter what. And the same goes with the fruit bars. Right? At the very least, it'd be okay for her to sell 5, so it can be equal to, and then needs to earn at least $25 per day, so that gets the same inequality. So now we can rewrite our system. We have x is greater than or equal to 5, y is greater than or equal to 5, and 2y plus 1x is greater than or equal to 25. So if you graph this, we can graph this. We graph these inequalities. X is greater than 5. Y is greater than 5. And 1x plus 2y is greater than 25. We can zoom out and we see where all of the shading intersects. Take a picture, crop it, and then we can put it in these notes here. And we can see on this graph that we've got some points we can identify that are possible solutions. I see a point here, and here it says to identify 2 points. So I see this first point. I see the scale is at 10, which means each of these units is 2, 2, 4, 6, 8. So that means this is 8 and 14. So 8 and 14 is a solution. 8 and 14 is a solution, and so is 10 and 18. 10 and 18. These 2 points are solutions, and we can show and describe all of them by graphing and noting the intersection of the shaded areas. If we move this graph down a bit, at least in this part, erase these. We can read the other word problem. Alice is serving pepper jack cheese and cheddar cheese on a platter. She wants to have more than 2 pounds of each. Pepper jack cheese costs $4 per pound and cheddar cheese costs $2 per pound. Alice wants to spend at most $20 on cheese. Graph all possible combinations of the 2 cheeses Alice would buy. Use a checkpoint to justify the reasonableness of the solution. So we can see here that if we note what's being counted, what repeats, we've got pepper jack cheese and cheddar cheese. Pepper jack cheese and cheddar cheese. And that's what's noted on the graph is pepper jack cheese and cheddar cheese. So I see that we're counting things and we're counting money, right? And of pepper jack cheese and cheddar cheese put together. There's always an and with it. It always means plus. And I see the things need to be no more than 2 pounds of each. So we've got a total of 2 here, the total of 2 for the pepper jack, which is X, and we've got Y here, and then money is $20 at most, with $4 per pound. Let's do this with money. With $4 per pound for the pepper jack and $2 per pound for cheddar cheese, and at most means this is the greatest, and wants to have more than 2 pounds of each, so more than 2 pounds, more than 2 pounds, and we can rewrite our inequalities. We have X is greater than 2, X is greater than 2, and we have Y is greater than 2, Y is greater than 2. We shade that in up top because it's getting bigger. And then we have our standard form, which if we look at our note card from before, we would solve for y to get it in y equals mx plus b. We have 4x plus 2y is less than or equal to 20 minus 4x. From each side, we get 2y is less than negative 4x plus 20 divided by 2. And if I divide one thing, I have to divide everything. And I get y is less than or equal to negative 2x plus 10. So we have this starting value of 10 all the way up top, and it comes down by 2 every time. So it comes down by 2, comes down by 2 every time, and it's less than or equal to, so I can connect this with a solid line, no arrows probably because it ends there, and then it's less than, so we shade below. I see the darkest part is this triangle right in the middle. Use a checkpoint to justify the reasonableness of the solution. I would use 3, 3 right in the middle of the triangle. So let's check that. If I put 3 in here, that means, so we're checking 3 and 3. X is 3 and it is greater than 2. Y would be 3. Y would be 3, which is also greater than 2, so that checks and that checks. And then we get 3, which is 6, and 3, which is 12. 12 plus 6 is 18, which is definitely less than 20, so that checkpoint verifies the reasonableness of the solution. If you look down on this practice sheet, we can delete this now. You have more questions to answer and to graph, and then some reflection questions for you to answer. And then you will practice all of these problems all the way to the very end of the activity.